All right, this is section 12.2, day 1, and we're going to talk about the surface area of prisms and cylinders. And today's going to mainly focus on the 3 prisms that we have. First, we're going to talk about a term called a net, which is just a 2D drawing of a 3D shape. So just imagine it being cut and unfolded. That's the word I'm looking for. So if we had a box and we cut all the edges and then kind of smushed it flat, unfolded it, it would look something like this. So each shape, if we were to cut it apart and like lay it out, has what's called a net for that shape. So it's kind of like the flat picture of that shape. We have things called right prisms and oblique prisms. What's interesting is whether it stands upright or it leans to the side, they have the same surface area and they have the same volume. So the formulas that you will use are going to be the same whether they're standing up straight or whether they're leaning a little bit. These first couple just say give the name of the net shown. So what would this make if I was able to cut it out of here and then fold all of these up and together? So these 2 triangles would kind of come and stand up, and then these 2 rectangles would lay on top. So this would be a triangular prism. There are more rectangles than triangles, so this will be a prism for sure. Next up, number 2 says a pentagonal prism. So a pentagon just means 5 sides. So I'm going to draw it like this. And then a prism means that there are rectangles off of each side, roughly the same size. And then I need one more pentagon somewhere so that I can kind of close the top of this shape. So all of these 5 sides will fold up and stand up tall, and then this one will kind of flap close on top. And that's just one way to draw it. Another way would be like this. So I have my 5 rectangles. That should be a lot more the same than that, but you get the idea. And then I just have to include 2 pentagons somewhere so that when I roll this up and I have my 2 ends that kind of close my shape up together. This last one, if I were to fold it all up, we would call it a cube. Could also be called a square prism. I am kind of assuming that these are all the same length. They look like that even though they're not marked. So let's try a couple of formulas. If you haven't filled them in yet, your surface area formulas are right here. So we've got the first prism, which is a triangular base. That's this one. The base of it is a triangle, and you have 2 of those. And then you have 3 different rectangles, and they are usually all different. Then you've got the box or rectangular prism, and every side measure needs to be matched up to make a pair. So you're going to match up 7 and 7, then you're going to match up 7 and 2, and then we're going to match up 2 and 7. So there's 2 of each of those sides. So like 2 top and bottoms to your box, 2 left and rights to your box, and then 2 front and backs. So we're finding all of those sides. The last shape you would have is something like this, pentagon hexagonal prisms, and their formulas start out with with A and S. The reason why it's not 1/2 is because you're going to have 2 of them. You're going to have the shape on the top and the shape on the bottom. So that 2 and the 1/2 kind of cancel each other out. So I'm just left with A and S plus, and then it's NSH. And N stands for number of sides, S is side length, and H is height. So let's tackle these 3. First formula is this one, so we're going to do the 2 times. We're going to make sure every side is matched up once. So my surface area will be 2 times, and 7 times 7 is my first match. 2 times 7 is my next match. And 2 times 7 is my final. So I have 2 times 49, and 2 times 14, and 2 times 14. Let's grab my calculator quick. And I get 154. This is yards squared. You're talking about area, so our unit is just a squared. Next up, we're going to do triangular prisms. These by far are usually the ones that students get wrong the most, and it's usually have to do with that triangle. It kind of messes people up. So that's where we're going to focus. We're going to start with that part. So the formula just has us doing the base and height of the triangle. So I'm just going to trace the triangle. And when I do that, it's kind of obvious that the 2 numbers I hit are 5 and 12, and they meet at a 90, so they are my base and height. So 5 times 12. That takes care of my triangle. Now I've got the 3 different rectangles to take care of. So first rectangle is on the bottom. That looks like it has measurements of 12 and 10. So it's going to be my length and my width. Next I've got this rectangle off to the left that's kind of standing up. And it's got a 5, and then this side is the same as this one. So that will be a 10. Your last one's kind of like the skateboard ramp part of this, so the slanted rectangle. It's definitely got a 10, and then it's got this side right here, which we're going to have to figure out. So it's going to be 10 times something. And we're just going to do a Pythagoras real quick with 5 and 12 to figure that out, and that side will be 13. So all I got to do is type all that in. Looks like I get about 360 centimeters squared. One more to go. So this is our 1/2 ANS type formula, and we don't need the half because we'll have 2 of those shapes. So we just start off with ANS. So A, and then number of sides, everybody can count that. So that's 5. Side length is 7.05. And the rest of the formula goes NSH. So I've got an N, number of sides, S, side length, 7.05. And then H is my height, and my height is 9. So the only thing it looks like we don't have is apothem. So I'm going to retrace that triangle right here. I know that this is 6. This is my apothem, straight through the triangle. And we know this side length is 7.05. So if I take 7.05 and chop it in half, because I don't want the whole side, I just want half of this triangle, this would be about 3.525. So we're going to do Pythagorean's theorem. I'm going to have 6 squared equals 3.525, and a squared, oh, that's not it. And it looks like once I square root it that I get about 4.8. We'll say 4.86. So that's what goes here. Now we just have to type in this long formula, all of our values. So 4.86 times 5 times 7.05 plus 5 times 7.05 times 9. Looks like it's about 488.4 feet squared. And that is just the beginning of surface area. The formulas are a little bit involved. You really got to pay attention to what you're solving for.